To go deep into the cosmos, humanity had to solve a terrifying math problem. A human being requires roughly 1.5 pounds of dry food per day to survive. That sounds manageable, but the math changes when you look at scale. For a 3-year round-trip mission to Mars, a crew of just 6 astronauts requires over 9,000 pounds of food, 4.5 tons. In aerospace engineering, mass is a brutal enemy. Every single pound of dead weight launched into low Earth orbit costs thousands of dollars in rocket propellant. More importantly, food degrades. Vitamins break down under cosmic radiation. You cannot pack a grocery store inside a capsule and expect it to sustain human life across millions of miles of empty void. In the late 20th century, NASA engineers reached a stark realization. If we wanted to survive among the stars, we couldn't bring our food with us. We had to build a machine that could manufacture life out of nothing. Enter the CELSS program, Controlled Ecological Life Support Systems. Launched formally by NASA, this was not an agricultural project. It was a thermodynamic optimization problem. The scientists inside the labs at Cape Canaveral weren't trying to plant a garden. They were trying to construct a flawless, closed-loop life support machine where biology functioned as the hardware. The loop had to be absolute. Every breath an astronaut exhaled carried carbon dioxide. The plants had to capture that gas and turn it back into breathable oxygen. Every drop of human wastewater, urine, sweat, humidity, had to be pulled through the root systems of the crops, purified by the plant's natural transpiration process, and breathed back into the cabin air as pure distilled drinking water. But biology is messy, and space is hostile. On Earth, farming relies on soil. In space, soil is a catastrophic biohazard. Soil is heavy. It takes up volume. In zero gravity, dry dirt doesn't sit quietly in a tray. It breaks apart, floats into the cabin, fouls delicate electronics, and clogs oxygen filtration systems. Worse, soil is teeming with unpredictable bacteria and fungi. In a sealed space habitat, a single rogue pathogen could wipe out the crew's entire food supply in days. NASA had to eliminate the Earth entirely. They started with hydroponics, growing plants in water solutions. It worked, but water has mass. Large tanks of liquid are heavy and difficult to stabilize during rocket maneuvers. Then a breakthrough occurred in a specialized laboratory at the University of Colorado, funded by NASA's Small Business Innovation Research Program. They turned to aeroponics. Don't picture a garden hose spraying dirt. Picture absolute precision. In an aeroponic system, the plant is held by a lightweight foam collar. The roots hang entirely naked in the air, inside a dark, sealed chamber. Every few minutes, automated high-pressure nozzles blast the roots with an ultrafine chemical mist. The water droplets are engineered to be between 5 and 50 microns in diameter, thinner than a strand of human hair. Because the roots are suspended in the air rather than buried in mud or submerged in water, they have 100% access to oxygen. The result was a biological explosion. Crops grew 300% faster. They required 95% less water than traditional farming and zero soil. NASA had successfully decoupled agriculture from the planet Earth. The space race didn't stay in the stars. During the late 1990s and early 2000s, geopolitical priorities shifted. The massive budgets for long-duration manned spaceflight contracted. The dreams of immediate Martian biospheres were shelved. But the data didn't vanish. The engineers, plant physiologists, and computer scientists who spent decades writing the software to keep plants alive in zero gravity walked out of government labs and into the private sector. They brought the blueprints back down to Earth. The exact mathematical models built to calculate the lighting spectrum for an astronaut habitat are the exact algorithms running the windowless ghost farms multiplying in our cities today. We didn't invent vertical farming because we wanted to revolutionize local grocery stores. We invented it because we were terrified of starving on the way to Mars. When you look at a modern warehouse farm in New York, Tokyo, or London, you're looking at a localized space colony. The building is sealed against the outside environment for the exact same reason a Martian habitat is sealed. because the outside world has become too volatile, too unpredictable, and too dangerous to trust. Humanity spent 10,000 years relying on the stability of the sky. We needed the rain to fall at the exact right week. We needed the temperature to sit within a specific 10-degree window. But as global climates shift, aquifers dry up, and topsoil erodes, the outdoor world is starting to look more and more like an alien landscape. The great irony of modern agritech is that the technology built to conquer the stars turned out to be the exact tool required to save us from our own planet. The ghost farms inside our cities are no longer experiments. They are infrastructure. They are the invisible systems quietly decoupled from nature, keeping the modern world fed using the logic of the cosmos. Every video on this channel maps a different corner of this hidden technological network. If you want to see how this space-age automation is scaling across the globe, from the automated drone swarms of the American Midwest to the glass fortresses of Europe, hit the subscribe button, click the notification bell, and step inside. Welcome to the Invisible Farm.